Welcome, mathematicians, to our lesson of mathematics for today, Thursday. It's October 1st already. Wow, we're here. Our lesson today is going to be about subtracting fractions using a multiplication chart. Now, of course, we know it's not going to only be about subtracting fractions. We're really going to be building on top of all of the work we've been doing when it comes to recognizing equivalent fractions. Whether we recognize an equivalent fraction or a fraction that's equivalent to 1. We know how to simplify fractions. We know how to look at two fractions, whether their denominators are common or unlike. Sometimes we say whether they're like or unlike. But today we're going to be really using all of these skills. And I was thinking about this, fractions can be challenging, but they're also very useful in daily life. So I thought we would have a little fun with this today and consider how to talk about fractions in the sense of a story problem that has to do with many things that we've all come into contact before. When we're baking, when we're eating dessert and cutting it up into pieces, and all of those things have to do with fractions. So today, we're going to continue. Look at this teaching point below. We are going to continue using a multiplication chart to find common denominators. We're also going to be able to subtract two fractions with unlike denominators by finding the common denominators here on our multiplication chart. Double check that you have your math notebook and a writing utensil so that we can get going. So we have some pretty exciting things going on. We're going to talk about this little story problem I have for us here, which is Mr. Wilson is baking 3 cakes. He bakes a chocolate cake, a vanilla cake, and a tres leche cake. Now, each cake is the same size. We have 2 people involved, Jess and Benny. Now, both Jess and Benny, they eat all 3 types of cake, but of course, there's some differences in how they eat it. So let's take a look. This is going to be some really great information to write down. We are noticing that Jess has eaten a quarter of the chocolate cake, an eighth of the vanilla cake, and half of the tres leches cake. We also know that Benny has eaten 2/8 of the chocolate cake, a quarter vanilla, and 2/4 of the tres leche cake. Now, we're going to do this lesson without making any judgments towards Jess and Benny and how much cake they've eaten. I'm not going and judging you for how much ice cream you've eaten during all this shelter-in-place business. So we're going to use our norms and not yuck Jess or Benny's yum. So let's consider, how can we get a sense of, there's a few questions that might be coming up for us, right? And in the chat, the thing that I love about word problems is right now, I haven't given us anything but information. There's no question that I've introduced yet. I've just given us these details. Now, knowing that Jess and Benny have eaten part of all 3 cakes, knowing that all of these are different denominators, right? But they do have this in common. I'm seeing a 4th in common, I'm seeing an 1/8 in common, and I'm seeing another 4th in common. So if you have any questions that are starting to come up, go ahead and write those in the live chat. What questions might you think will be asked for you to identify, especially considering our teaching point and considering well, both of our teaching points really, right? If our teaching point is about subtracting, what might we want to know about this? So I'm going to give a little bit of think time in the chat, and then this will also give you some time to write these down. So I'm going to stand off to the side and give a little bit of quiet think time. What might be asked of us as mathematicians, having been given this information? Having been given this information. Now, something I love is, considering when we do get a question, well, even before we get the question, is really taking more than one time to read through this problem. So I really want to go through this again, and we're going to read this problem, and then I'm going to introduce the two questions that are going to come up. And hopefully by then we'll have some other students who've identified questions they have about this cake fraction equation, right? So let's read this through this again. Mr. Wilson bakes 3 cakes: a chocolate cake, a vanilla cake, and a tres leches cake. Each cake is the same. That was important. Each cake is the same size, not the same, because they're different cakes, but they're all the same size. Okay. Now, let's consider a first question, which is, who eats more cake? Jess or Bonita? Or Bonita. Benny. Jess or Benny? Now, I'm going to write down our questions over here on this side so we can keep a clear space of where to keep track of our questions. So who has eaten more cake? This is the first question that we are going to explore. And really, many of us want to, there it is, Quincy. Who ate more cake altogether? Absolutely. So that is that very first question. Who's eaten the most cake? And then we want to be able to represent this, not just in words, but also in a visual. So once we figured out who has eaten cake more, I want us to be able to show this in 2 different ways so that we really have a deep understanding of how to compare fractions of unlike denominators, and then find the common denominator so that we can properly compare and then add up the pieces. Now, after we quantify how much cake has been eaten by each person, we can definitely compare the two and let us know who has eaten the most cake. Well, that was our first question, but not just who has eaten the most cake, but how much more cake was eaten, right? How much more cake? How much more cake was eaten? And the extension question that is going to be a bit more difficult is considering our 3 cakes. How much of each cake is left over? How much is left? So when we are given a word problem, there's a handful of stuff happening here. When we're given word problems with more than one question, it's so important we understand what the question is asking of us. Now, if you've gotten a different, at the beginning of this, I asked you to consider what are some questions you think are going to be asked. If you have a question that's not up here, go ahead and put that in the chat so that we can consider that as a community. But really, it's our job as mathematicians to really make sure we understand what the question is asking us to do. So, number one, let's read through this again. Who has eaten more cake? These are the words that stand out to me. Who and more. I want to know, is it Jess or Benny? And I really need to know whether that is my answer. It's going to be a name, right? It's asking me who, not how much. This is a big difference, right? How much more? Look at these more. More typically tells us that we are comparing and adding. Now, this is why I really, took the time and wrote how much is left in each cake. So we're going to need to do some subtraction to find these out. Okay. So we have all of our cakes are the same size. Now, part of me being a visual learner to get started on this, and we're really trying to get started with number one. Nope, don't want that one. Here we go. All right, we're in business. So really, I want to give us a space where we are going to represent this in a few different ways that we have that we've learned. So one thing I really like is considering doing an actual drawing of the cakes that were eaten, okay? Now, when I think about this, I think of like doing a box drawing. So for my chocolate, I'm going to use brown. So I'm going to draw my chocolate for Jessica and my chocolate for Benny. Okay, now I'm going to look at these two chocolates. This one says 4, that it was split up into fourths. So I'm going to split mine up into fourths. I like to do my fourths by cutting it in half and then cutting each half in half. Right, and then we've got 1, 2, 3, 4. Now we have only 1/4 was eaten by Jess. So we know how much cake is left over. If I take a whole cake, 4/4, right? One whole cake is 4/4, and I take away that piece that Jess ate. That leaves me with how many fourths, right? Nothing's changed. We still have the 4 pieces that it was cut up, but we now have 1/4 left, plus 1/4, plus 1/4. We're just adding the numerators. Remember, the numerators represent the pieces of the whole. So with our chocolate, I'm just going to kind of keep this note up here that I have 3/4 left. Now, I'm a little concerned because I see that fourths up top, but Benny had 2/8 of chocolate. Now, I can approach this in one of two ways. The first way that I might say is I'm going to do it the same way where I know that this is technically the same cake. We don't have 2 chocolate cakes. But I want to represent this out with 8ths. So I'm going to draw this in 8ths. I'm going to draw in half, and half my halves. That gives me 4, and then I'm going to half each of my halves, and that'll give me 8. And I'm going to count just to be sure. 1, 2, 3, 4, 5, 6, 7, 8. 8 pieces matches my 8th denominator. Now, you might notice something dinging off in the back of your head. You might be Mrs. SJ. You've taught us how to simplify fractions or how to identify when the numerator and the denominator have a factor in common. We know that 2/8 is equivalent to 2/4. And, you know, I have, or excuse me, 2/8. Check it out. Is the same as 1/4. I know this because I can divide 2/8 by 2/2. And that'll give me, what's 2 divided by 2? 1. What's 8 divided by 2? Oh, I think I heard someone say 4. Yep, that's right, 4. Now, that means that 1/4. Did they eat the same amount of chocolate cake? Is 1/4 the same as 2/8? So I'm going to wait. I love getting responses in the chat, and I know there are 12 of you watching. So really, I'm trying to get people to respond and be interactive as possible, as much as possible, if you are watching this live, okay? If you are not watching this live, I am so happy you're here. You are able to write comments below, and they will need to be approved, so you won't see it right away. Thank you so much, Ava. Absolutely, they are the same. Jess and Benny ate the same amount of chocolate cake. Now, being the really diligent mathematician that I am, I was keeping track. Of how much cake I had left over. Well, if I know that 2/8 is equivalent to 1/4, right? Those are 1/8 plus 1/8 equals 2/8. And I know that I can divide this by 1/2, or 2/2. We determine that that equals 1/4. Well, this is actually 1/4 of the same chocolate cake that Jess ate. So we don't have two separate cakes. I'm just drawing them differently for each person. But we know that technically, if this was the same cake, that Benny ate 2 pieces. She just maybe cut it in half to, like, because we all know maybe we have family members who are like this, who are like, all right, I'll just have just a sliver, just a small piece of cake. That's all I want. And then they end up getting like 2 small pieces of cake because it makes them feel better. That's probably what Benny was up to. They were like, no, I don't want that much. You know, I just really want just a small little sliver of cake because it's really good. And then they go back for seconds, right? So I have a suspicion that was what Benny was up to, was, you know, trying to get away with just getting a small sliver of 1/8 and then came back for seconds. So we know that we have 3/4 left over. Well, what happens if I take away another 1/4 away from 3/4? Now I have how much left? Look how much is blank. I have 2/4 left of my chocolate cake. Woo! Now that is something I'm keeping in the back of my head because I still need to figure out my first question. Who has eaten more cake? Let's keep moving. And you know what? I'm going to make Benny's eaten pieces. I'm going to keep this up. And I'm going to show Benny's part that Benny ate in this blue, darker blue marker. Okay, so we know that Benny ate that much as well. Okay, so that's our chocolate. We have vanilla left. Okay, vanilla. let's draw our vanilla cake. So our vanilla cake, let's take a look. This was, ooh, we're still using these 1/8 and 4ths. Excellent. So we are now feeling pretty confident that 1/8 and 4ths are related, right? So let's take a look. Well, Jess ate an 1/8 of vanilla cake. So that means I'm going to really, I want to show that our vanilla cake was split up into 1/8 to begin with, okay? And knowing what I know about fractions, when I see a number with a bigger denominator, that means it's a smaller piece. So I have a feeling Jess, after having that chocolate, was like, I just want a little taste of the vanilla. Right? We have to think of like the reasonableness of it. So remember my trick. I draw a half to get 2, I half my halves to get 4, and then I half my 4s to get 8. And then I double check my work as a mathematician. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8. That matches my denominator, telling me how many parts are separated. Now, we know that Jess has eaten 1/8. So I'm going to go ahead and represent what Jess ate with her brown marker again. All right. So that is just a small piece. Really small. Now I want to represent how much Benny ate. Now I might be feeling a bit stuck because I see 1/4 and that makes me nervous because I have 1/8. Now based on what we just learned, we could use our previous knowledge, but I want to represent our thinking, okay, by showing how we can use this to get to a common denominator. Well, I know that 4 and 8 have something in common. I know all I need to do is multiply something to my 4th so that it matches 8, right? Because I know if I look at my 8s and my 4s, check out what they have in common immediately. You can't because it's so far away and it's probably a little blurry. Come close, darlings, come close. Okay, take a look. If we look at our multiplication chart, we've got our 4 and we've got our 8. Tell me when to stop when you see a match. Oh, stop. There we go. We got a match. We got a match, kids. So that means I need to multiply my 4 by 2 so that I can get to 8. I don't need to do anything with my 1/8 because it already has the 8. Okay? So when I multiply 1/4, because remember now, nope, too far. Here we go. Thank you. Woo! We know that Benny is the one that we're trying to represent on our vanilla cake. So we just need to multiply it by 2/2. Just like we identified. And we know when we multiply any number by a fraction equivalent to 1, nothing changes. It really doesn't. So that's going to equal 2/8. So I'm going to add up and represent that Benny ate 2/8 of the vanilla. Or, as we know, 2/8 is equivalent to 1/4. So that really was 1/4 that she ate. Okay. Woo! So far, we can make some observations, but we still need to figure out who has eaten more cake. Right now, if we were going to stop and didn't even think about the tres leches, well, I'm just looking here. I know that 1/4 plus 1/4 equals 1/2. Right? I know that 1/4 plus 1/8 has got to be less than half because an 1/8 is less than a 4th. Right? So these are things that we are trying to make sense of as we're going along. So interesting. So let's do the tres leche. Ooh, how many of you love tres leche cake? Oh, I can't get enough. There's this delicious Mexican restaurant called Los Moles, and they make such good tres leche. It's actually like in just a small little serving, and it's the most delicious thing ever. So I am Not surprised. I'm seeing some big numbers. I feel like the tres leche was the most popular out of the two. And we can, let's see if my claim is correct by how much they actually did eat. So our tres leches, I'm going to use this really delicious kind of brown color. Now remember, our cakes are all the same size, even if I'm not drawing them exactly to scale, okay? And we are going to make sure that we are splitting it up. Well, I see this one has a 4 and this one has a 2. Let's go ahead and split it up into 4, and we'll convert to this number. So I've got 2 pieces. I need to split it up one more time so that I have 4 pieces. Cut my halves in half, and then I get my fourths. Okay? Let's represent how much Benny has eaten, since we're already in the fourths. Okay? Well, let's take a look. 2 of the pieces have been eaten by Benny. Is that ringing any bells for anybody? Looking at that, 2/4. Part of me is starting to gain, and what I'm hoping that is happening with you is that you're starting to see patterns. When you see certain numbers where the top is exactly half of the bottom, that means that it equals 1/2. This should start coming up for you now. Like automatically. You're like, 2/4 is 1/2. What are we doing here? 4/8 is 1/2. 8/16 is 1/2. 5/10 is 1/2. What else is a equivalent to a half? That rings those bells. That's like, okay, ding, 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 ding. This is 1/2 or 1/4, right? Anytime we're gonna see 2/8 now, it should go in your head. Ding, 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 ding. 2/8 equals 1/4. This should start coming up very quickly for you. So I'm noticing a few things. Knowing that 2 is half of 4, it's going to be no surprise when I say I need to convert 1/2 so that it has a like denominator. Well, what do I need to multiply 2 to get to 4? 2. 2 over 2 times 1/2, that equals 2/4. Students, is there going to be any tres leche cake left over? Oh my gosh, I love it. Look at all of these kiddos writing equivalents to half. I love it. Shout out to Quincy and Ava and Dermot. Well done. Now, we've done a whole lot of math together. The exit ticket, which I'm not going to lie, I'm late to posting, is going to be answering our 3 questions. We've done all of the math. Remember, the blue represents how much Benny ate. The brown represents how much Jess ate. But we have our 3 questions left over. Now, I'm going to say until I post it, go ahead and write it by hand. You also can upload your answers by just taking a photo of what you did by hand. I want to know, between all these kiddos, who has eaten the most cake? How much more cake was eaten by that person who ate more? And how much is left in each cake? And so with that, this concludes our lesson for today. And I'm going to quote a very famous Marie Antoinette, who did once say, let them eat cake. And I'm going to say, whether or not you have cake in your future today, I hope that you will get to eat cake at some point in your future. And with that, we are ending.